There's several ways to prevent a pathogen from causing disease. And the way that I'm interested in is actually adjusting the landscape of the human body to prevent the pathogen from being able to exert damage in the colon in this case for amoeba histolytica. We took a discovery-driven approach where we looked at every gene in the human genome in a whole genome library and selected those cells that were resistant to killing by amoeba histolytica. So the strength of our approach in going after host factors rather than parasite factors is that by inhibiting the ability of the parasite to kill the host cell on the host side, it removes any selective pressure from the parasite to evolve resistance. So when we got the results back from the next-gen sequencing that told us which cells were more resistant to amoeba histolytica killing, I was very surprised that potassium channels were a heavily overrepresented category, and we were encouraged because we were actually able to validate the role of potassium channels in intestinal cells to prove that the effect that we saw in the genome-wide screen wasn't due to random chance or some artifact. So our challenge is identifying ion channels, potassium channels in particular, that are unique to the human colon that could be targeted to prevent cell killing during amebiosis. So the most exciting part of my research is that I have the ability to integrate data from our clinical trials in Bangladesh and access to the state-of-the-art tools at UVA and technologies and wonderful collaborators so that I feel like every day our research is directly contributing to improving human health.